Hello students, I am Saransh Kalra and today I am going to teach a trick to find peroxide linkage in any inorganic compounds. Students, in our competitive examinations like NEET and JEE, right now this is the trend that most of the time it is being asked that which compounds has a peroxide linkage, whether it has a peroxide linkage or not having a peroxide linkage. So today I am going to discuss the trick to find peroxide linkage in any inorganic compound. For example, let's start with the example H2SO5. By the simple classification method, we will calculate the oxidation state of sulfur. Hydrogen has an oxidation state of 1, 1 into 2, it comes to be 2. Plus sulfur has an oxidation state, we have to calculate, so we take it as X. Oxygen has an oxidation state of minus 2 into 5, it comes to be minus 10, equals to, the compound is neutral, so it is 0. So X minus 8 is equals to 0. X is equals to plus 8. So right now the oxidation state of sulfur by this classical method is coming as plus 8. But we all know that sulfur has atomic number 16, valence electron 6. So it can has a maximum oxidation state or the common oxidation state. We can say the common or the maximum oxidation state of sulfur can be plus 6. But according to our method, it is coming to be plus 8. So here is the trick. If any element is showing oxidation state different from its common or the maximum oxidation state, it has peroxide linkage. I am repeating the trick. Like in this compound H2SO5, sulfur has an oxidation state of plus 8. But sulfur has a maximum or the common oxidation state of plus 6. So it is having a common oxidation state plus 6, but according to the classical method it is coming to be plus 8, which we have calculated. So that's why as there is a variation from plus 6 to plus 8, so it has a peroxide linkage. Students, let's take another example. Next comes to be H2S2O8. We will calculate the oxidation state of sulfur. Same, hydrogen 2 plus, as there are 2 atoms of sulfur, so it comes to be 2x. Oxygen has an oxidation state of minus 2, so minus 2 into 8, it comes to be minus 16 equals to 0. 2x minus 14 is equals to 0. 2x is equals to 14. X comes to be plus 7. Very easy for us. Sulfur has a common oxidation state of plus 6, but according to this method, it is coming to be plus 7. So there is a variation from the highest oxidation state, so this is coming to be plus 7. So it means what we have taught in the trick, that any element showing the variability in the maximum oxidation state to another oxidation state, it means peroxide linkage is present in this. Same, third number, I am giving another example of also. You all know about CrO5, chromium oxide. X, we are calculating the oxidation state of chromium. X, oxygen minus 5 into 2, it is comes to be minus 10. As a neutral compound, so equals to 0. X comes to be plus 10. But we all know the atomic number of chromium is 24. Electronic configuration, argon 3d5, 4s1. Valence electron total is 6. So it can have a maximum oxidation state of plus 6, but it is showing plus 10. So as there is a variability in the oxidation state, that's why it has a peroxide linkage. Let's take another example. Simple, H2S2O8. We have covered that example, so that's why I'm just changing the number from O8 to O6. Please see this. H2S2O6. Let's take, we will calculate the oxidation state of sulfur by the same method. Hydrogen 1 to 2 comes to be 2 plus 2 atoms of sulfur, so it comes to be 2x. Oxygen has an oxidation state of minus 2. minus 2 into 6, it comes to be minus 12 equals to 0. 2x comes to be 10, x comes to be plus 5, but sulfur has a maximum oxidation state of plus 6. As it is coming to be plus 6 to plus 5, there is a variation from the highest oxidation state, so that's why H2S2O6 has a peroxide linkage. Last but not the least, it's a very easy concept. Everybody know that this is called as hydrogen peroxide. So definitely it must be having a peroxide linkage. But let's prove this by this trick. We will calculate the oxidation state of oxygen. Hydrogen 2 plus 2x equals to 0. So 2x comes to be minus 2. X comes to be minus 1. Oxygen has a maximum oxidation state of minus 2. But here it is showing minus 1. So as there is a variability in its oxidation state, so that's why the peroxide linkage is present. Let's revise this whole complete trick. I thought everybody of you would be able to understand this trick, but I'm just revising whole of these examples so that this trick would be completely clear to everybody of you. H2SO5, we will calculate the oxidation state of sulfur. It comes to be 2 plus x minus 10 equals to 0. X comes to be plus 8. What was the trick? Sulfur has a maximum oxidation state of 6, but according to the classical method it is showing plus 8. So as there is a variability from plus 6 to plus 8, so that's why this has a peroxide linkage. Another example, H2S2O8, sulfur oxidation state being calculated plus 7, highest oxidation state plus 6, variability in the oxidation state, so peroxide linkage is present. CrO5, a blue colored compound, X comes to be plus 7, chromium oxidation state plus 10. But according to our concept, we all know that chromium can have a maximum valence electron plus 6, so it can show a maximum oxidation state of plus 6. That's why it also shows that according to our trick, there is a variability from the maximum oxidation state to oxidation state which we are calculating. So that's, yes, there is a variability, so that's why a peroxide linkage is present. H2S2O6, sulfur coming with oxidation state of plus 5, but sulfur has a maximum oxidation state of plus 6, variability from the highest oxidation state, so that's why peroxide linkage is present. Last but not the least, H2O2, it comes oxygen has an oxidation state of minus 1, but here oxygen is showing oxidation state of minus 2. Minus 2 is the highest oxidation state of oxygen, it is showing minus 1, variability in the oxidation state, that's why peroxide linkage is present. I hope everybody of you must understand this trick, and this is a very useful trick for competitive examinations. If you like it, just share it with your friends and subscribe to my channel. Thank you.